Hello everyone. In a previous video, we observed what are the do's and don'ts of HTTP context. Now let's go ahead with the HTTP request and response do's and don'ts. We will cover a little bit of a do's and don'ts of a controller. I have uploaded another video for the controller and the middleware and the filter also. It's really well explained on the ASP.NET website. So I have added that video also. So let's start with the HTTP request and HTTP response, do's and don'ts. Let's start with the HTTP request first. Do's, first we have to validate and sanitize all input data. Okay, whatever data you are fetching through the request, we have to verify and validate the data very properly. Check appropriate or use appropriate HTTP methods, get, post, put, delete. So I hope that if you are using APIs, then these methods are really, you are familiar with these methods, when to use which method, and use the appropriate methods when you are requesting. So we can fetch it in a proper way. We can fetch the data by means of a request object in a proper way. Include necessary headers, mention the content type, authorization, and some additional filters you want to add. Use HTTPS for the secure communications and handle the request timeouts gracefully. Okay. You have to point out, you have to notify the user with the proper message, and whatever the communications are, critical communications are there. So for those communications, you can go ahead with the HTTPS. Now, what are the don'ts in case with HTTP request? Don't include the sensitive information in a URL parameter. Obviously, if you are sharing something, it is visible. If you observe the address bar, it is visible over there. So don't share the sensible or important information or secured information through the URL parameters. Don't ignore the response codes or error handling. So there are different response codes are available with the response object. Don't ignore, understand each and every code and properly handle those code in a proper way. Notify the user, mention those code and mention the appropriate message for that code. Don't send them unnecessary data in a request. Whatever you want, that much data, share with the request. Don't use get request for operations that modifies the data. So obviously we know that the get requests are not that much secure. So don't use the get request for the operations that are including some modifications about the data. Don't hard code the credentials and sensitive informations within the request. So these are some do's and don'ts about the HTTP request. Now let's go ahead. HTTP response. So there are some do's and don'ts about the HTTP response also. Set appropriate status code when you are responding. 200, as we mentioned in the request also, if you are getting some status code to handle that error and that kind of a thing. 200, obviously for the success, you can display whatever what you want in your view. 400 for client error, 500 for server error, and etc. There are a huge number of different errors are there. So set appropriate errors. Then include relevant headers, structures response data consistently by using JSON or whatever the pattern you are using. Implement proper error handling and informative error messages. This thing we have already discussed. Use compression of large response end when appropriate. As we have discussed this in a previous section also, in a best practices one also. If you are sharing huge amount of data, just send that data in a bunch format or some kind of display that data in a pagination format and share it parcel by parcel, right? So what are the don'ts? Don't expose the sensitive information in a response. Don't return overly verbose error messages in a production. So the error message should not be that much long and complicated. Make it simple and easy. Don't ignore secure code errors. Ignore security headers. Okay. Like content security policies are there, different protections layers and different protection there are things there are some restrictions headers are there. Okay, if you are using some third party and kind of a things, license are needed and all. So don't ignore those kinds of errors or headers if you are responding such kind of a data. Put those things in your response as well. Don't return inconsistent data structure. Don't send large payloads without pagination. And remember, always consider security, performance, and user experience when working with the HTTP request and response. Okay. So these are some do's and don'ts of HTTP request and HTTP response. Now there are some few more best practices which are mentioned. Complete wrong running tasks outside the HTTP request. Okay. So collection of a data, performing some business logic, these tasks should be outside of this HTTP scope. Okay. So do something, get prepared, and then we can get ahead with those things with the response. So most requests to the ASP.NET Core app can be handled by the controller or a page model calling necessary services and returning an HTTP response. So for some requests that involve wrong running tasks, it's better to make entire request response process asynchronous in that case. So what are the recommendations in that scenario? Do not wait for the long running task to complete as a part of ordinary HTTP request processing. Do consider handling wrong running requests with the background services. So create a separate background services for those long running tasks and make it async, and by means of which you can go ahead. Or out of a process, possibly with the Azure functions or using some message brokers like Azure Service Bus, and completing work out of process is especially beneficial for CPU intensive tasks. So where we are doing lots of input and outputs are some third party APIs we are fetching, or some database connections are going on. So in that case, you can go ahead. So do use real time communication options such as single R to communicate with the clients, asynchronously, or RPC, and many more different facilities or components you can use. Okay. So this is the perfect way to complete the wrongdoing task outside of the HTTP request. Now, don't assume that the HTTP request contentlet is not null or it's not empty. So HTTP content length is null if the content length header is not received. So null in that case means the length of the request body is we don't know. Okay. It doesn't mean that the length is 0. If we don't know the length, it's not like that. Okay, it's 0, because all comparisons with null except double equals to returns false to you. The comparison request dot content should be greater than 1024 for the for examples. So might return false when the request body size is more than 1024. And not knowing this can lead the security holes in your apps, and you might think that you're protecting against too long requests, and when you are not doing that thing, right? So don't consider it, verify it. So it's not like it's not available, so it's not there. Okay, so you have to verify that thin lines between the codes. Now there are some do's and don'ts regarding the controllers as well. So see, each module given or each component given its own task. Okay, don't combines the functionalities of different modules into the one for simplicity, and for it's working now, it's perfectly all right. It's not like. So keep the controller clean. So controller should only dispatch work to our services such as validation, database access, applying business logic. So then error and exception handling, mapping, returning values. Don't use the HTTP context after the HTTP request is complete. We saw these points lots of time. HTTP context is only valid when there is an active HTTP request. Don't mix concerns. Okay. Controller should focus on handling HTTP requests, generating responses, delegate other responsibility to separate the classes or a middlewares. Okay. So some whole functionality, whole components require something, then go ahead with the middleware. Specifications are then go ahead with the classes. But don't combine the concerns, don't mix the concerns. Okay, controller only should receive the HTTP response, call some kind of a third party business logic or classes or models, and from which get the data, send back to the HTTP response. That's it. This is the only functionality of a controller. Don't write too much code inside the controller. Now again, if we see the controller methods, okay, so I can see the huge amount of code is written over there. Don't do it. Don't directly inject the I configuration into the controller. Use the option patterns instead. Don't create the web API controller by delivering from the controller classes. Control is only for handling web pages, not for the web API requests. Okay. Do use built-in framework validations. So it works, this will work on a simple problems. Don't complicate your code, make it simple, make it easy. Okay. Do use dedicated result objects. This makes it easy to for the people to understand what is wrong. Okay, so if you are developing the application in a team, so use that dedicated results option for the specific task. So it will make for other people to understand. So do separate your API model from your entity model. So this prevents you from the exposing internals of your resource structure. So I given some kinds of reference links here. That thing we will visit one by one. But next, do not capture the services injected into the controller on the background thread. So this is the one best practice. Okay, don't mislead these things. Most requests to the ASP.NET Core app can be handled by the controller or a page model calling necessary. So returning the HTTP response for some requests that involve long running tasks, it is better to make the entire request response process asynchronous. So this is also related with the controllers. You can go ahead some extra or async way or some background services, or you can create another different model for that thing or different component for the such kinds of a long running task. Okay, now let's go ahead with the different blogs links I have shared, and I mhm. So learn how to improve your ASP.NET Core controllers with these principles. Okay, so healthy APIs are there, then return values, properly use the return values. Then you can controller does too much. Check whether your controller is doing everything for you or not. So it should not do that thing. So now somebody is consuming our API. We have to look at the controllers and we see it doing one or many of the following things. Okay. It's doing validations, database access, applying a business logic, error and exception handling, mapping, and result returning some value. And not a healthy thing to do in a controller. Okay. Controllers are delegates that tell other classes to do something. They are just distributors. They are distributing the task to the other components. Okay. And it's like waiters. Okay. They are not creating the food. They are just transferring food from the kitchen to the table and table to the kitchen like this. Okay. That being said, you should see to it that your controllers really just dispatch work or to the other services or not. So, for example, in an input validation can be done using the framework methods, or data retrieval should be done in a services using the repositories, or kind of a mapping could be done in the exact same service already. So exception handling should definitely not be dealt with an controller, but more on latter. Also, business logic does not belong to the controller either. So please keep your controller clean for all that. So validations, as far as validations goes, there are different options to reach the similar outcomes. So use built-in frameworks available. Use extended frameworks are available for the validation. Use separate validator class. Okay, directly create an object and call that class inside your controller. Then in that case, okay, error reporting should be separated. Then data encapsulation, separate your API model from your entity model. Okay, So when you are using the full featured set of an entity framework, even letting the scaffolding tools generate the controller for you, your code will end up publicly shipping your entity model via your API. But option one, you don't want to make the internals of your resource structure visible to the world. And second, you don't want to make the people provide the properties they are not interested in. So obviously, consequently, you are likely to need to separate the entity models for such kinds of operations. So let's consider our famous employee model. Internally, the class might look something like this: ID, first name, last name, and very sensitive information. Very sensitive information might be the social security number or kind of a private information you want to keep for the employee. And in any case, you don't want to expose this information when delivering these entities via your API. So you will need a DTO for that. Okay. So employee, now that's better. Okay. So what we have done, we have created one employee response DTO, and now that's better. Now ID of the entity will be useful to request a single employee from your controller. But what if somebody wants to add some employee uh, through your API to another DTO? So this is the way to do it. So we just mentioned first name and last name. So like this, you can go ahead with the multiple security ways and all. Let's go ahead with another link. What is exactly? There are some videos also regarding it. I hope that that video I have attached. So there are 10 best practices to avoid the ASP.NET Core in a API controllers. Not using attribute routing. So imagine your API is like a menu in a restaurant and you need to organize it by putting the labels on each dish. Okay, and now endpoints are there, consider. Without these labels, it's not like a menu with no, it's like a menu without no section, making it hard to find what you want to order, right? So this is the, what is C? There is the bad practice and good practice. Okay. API controller, route API. Okay, so they mentioned it. HTTP get data instead of a that get data. Okay, so instead of adding extra labeling and all these things, okay, so you need to organize it by putting the labels on each dish. Without these labels, it's like a menu with no sections, making it hard to find out your order. So that don't put the extra labeling and all. Go with the simplest thing. Exposing sensitive information. So for the bad practice, good practice is already given. You can go through it. Okay, this particular link is attached. Next, again, 10 things you should avoid in your ASP.NET controller. Data access logic, don't. Business logic. Then what we need to, mapping model class manually. Then exception handling, repetitive logic. Lots of instances are there. I have observed these things. Okay, so avoid it. Manual authorization, synchronous code. Okay, it's again lots of waiting for the response. Then these are the things: synchronous code, then manual authorization, then repetitive logic, exception handling, then mapping model classes manually, business logic, and data access logic. So these things, what you need to do, you need to avoid these things inside your controller. So hope that these things are beneficial for you. Let's go ahead. What we have next. Yes, middlewares and filters. I directly gave a video which is available on the ASP.NET website, official one, and which is really good. So again, if you want some extra material for the middleware versus filters, it is available. So I hope that it will be beneficial for you. If you have any queries, we will try to resolve it in a Q&A session. Take care. Bye-bye.